Let's look at the anatomy of a JSON Web Token, or a JWT. Here is a signed JSON Web Token. We're not going to look at encrypted web tokens in this video. All signed JSON Web Tokens have three components. There's the header, which is in green. There's the payload, which is in blue, and then there's a signature, which is in tan. Let's look at each of those. The header and the payload are both base64 encoded, and you can basically cut and paste them into any base64 decoder that you have, and you'll see the JSON. And this is something that's very important to realize about a signed JSON Web Token. The contents of a JSON Web Token, if it's signed, are not secret. Anyone who gets their hands on them can look at the contents. What they can't do is change them without the signature check failing. So the line above starting with EYJH and the 4 lines below are equivalent. This is a JWT header. You can put metadata about this token in here. So the algorithm that was used to sign the JWT and other information go in the header. The payload is where things get really interesting. So the payload is, again, another JSON object. The keys of the JSON object are called claims, and some of them are standardized and others are not. So let's look at each of these claims. The first is ISS, which is the issuer of the JSON Web Token. So in this particular case, it is a domain name, but it could be other types of identifiers. It could be a UUID, it could be a random string, it could be a package name, it could be a URL. That's a very common one. There are lots of options for this. But the whole point is that when you are consuming a JSON Web Token, you should know who the issuer is. So there's got to be some level of coordination out of band between whoever's generating the JSON Web Token and whoever is consuming it to make sure that there's no surprises. The next claim is the EXP claim, and this is the number of seconds since the Unix epoch after which this JWT will no longer be valid. Because JWTs are stateless, because they're self-contained, you need some way for them to become invalid, and the solution is that they're time-based. So you can actually set a JWT with a different claim not to be valid before a certain time. That's the NBF claim. But every JWT that I've ever seen has an EXP claim as well, which says after this time it is no longer valid. So as far as checks for that, you want to make sure that if you have a JWT and the EXP claim is in the past, you don't treat it as a valid JSON Web Token. The odd claim is another important one. This is a identifier for who this JWT was created for. So you could imagine that you might have an identity provider. Again, the ISS claim represents the identity provider that generates JWTs for a number of different services. And some JWTs are designed to be consumed by service A, and some JWTs are designed to be consumed by service B. Well, you wouldn't want a JWT that was created for service A to be presented as service B, because it might lead to escalation of privilege, it might lead to bugs in the code. If there are claims in a JWT for service A that just don't make sense in a JWT for service B, as you check your JWTs for validity, you want to make sure that you check the audience claim and ensure that whatever the identifier is there, because again, the identifier can vary. It can be a UUID, as in this case, or a string. Whatever that identifier is, it refers to the piece of software currently consuming this JWT. If not, don't even bother to pass it on any further. The subclaim is who this JWT is about. So those are the 4 claims that are in this JWT that are standard. One thing that's important to know, as I've alluded to, is that the meaning, the semantic meaning of each of these claims is fixed for these standard claims, but the value is not fixed, except for the EXP claim, which the format of the value is fixed. But the other claims, the ISS claim, the odd claim, the subclaim, they can all be represented as anything that's unique. And so that's one thing when you're looking for interoperability between systems, or you're looking to migrate between systems, you want to make sure you have a good understanding of what these values are. The other two claims there, the name claim is registered but not standardized. And so there's an IANA registry that has a list of JWT claims. And then roles is unregistered and not standardized. And so that is the Wild West. You can put whatever domain specific information into a JWT that makes sense for your application. I do want to point out that roles show that you actually don't need to have the values of the JWT claims be JavaScript primitives or JSON primitives. They can be nested objects, they can be objects of objects of objects, they can be arrays of arrays of arrays. So there's a lot of flexibility here with a JWT payload. And that's one of the strengths of JSON Web Tokens, frankly, is that you can actually turn this string into this complicated object and vice versa. So if you want to put in more values, again, as long as they aren't values that need to be kept secret, don't put government IDs or social security numbers or anything like that in a JWT. As long as it's okay for the values to be exposed, you can put them into a JSON Web Token for consumption by other services. Finally, there's the JSON Web Token signature. When you create a JWT, you take the header value and the payload value and you append them, and then you run through a cryptographic algorithm that creates basically a hash. And you do that when you create a JWT. You can also do it when you're consuming a JWT. So this is what the signature validation means. So the entity that is consuming the JWT can take that same header, take that same payload, and run through the same cryptographic algorithm. And if the signature it generates matches the signature that is appended to the third clause of the signed JSON Web Token, then it knows that the JWT was not tampered with. And so the contents of that JWT can be trusted. And that's a big win. So that's a quick overview of the components of a signed JSON Web Token.